Hi, my name is Kirk Marshall. In this module of Network Security Testing with Nmap, we'll be discussing Nmap's phases of operation and presenting some of the basic options that control input and output from the command. We've already seen a simple Nmap command and its screen-based output. Using the default settings is fine for some situations, but it's noisy and kind of like dropping a bomb on the target. If we want to get stealthy or surgical and pinpoint a specific target, we need to gain better control of Nmap through the plethora of options available to us. Using these options, we can graduate from dropping bombs to flying missiles through open windows, down hallways, around corners, and blowing up a single bathroom instead of an entire city block. In this module, we'll start to learn about Nmap's options and the power they provide to us to control Nmap and have it do our bidding. The major phases of Nmap's operation are listed here. We'll be talking about each one of these throughout the course, but in this module we want to focus on target expansion, reverse DNS resolution, port scanning, but only as it pertains to specifying the target ports, and output. As we've already seen, the simplest way to specify a target to Nmap is to give it the IP address of the system we want to scan. With this simplest argument, there is no expansion that Nmap needs to do. Nmap operates directly on the IP address. We can also use the DNS name for the target. Nmap translates the name into an IP address using standard DNS resolution requests. Multiple IP addresses can be combined into one argument using lists. Multiple values for each octet of the IP address can be listed at once by separating the values with commas. In this example, we have two lists. In the third octet, we've specified 54 and 55, and in the fourth octet, we've listed both 1 and 10. All lists are expanded in all combinations, so in this example, Nmap will scan for 4 IP addresses: 192.168.54.1, 192.168.54.10, 192.168.55.1, and 192.168.55.10. Frequently, we want to designate a range of IP addresses, and Nmap allows that using a dash to define ranges. In this example, Nmap will expand the range to 192.168.64.20 up through and including 192.168.64.29, so a total of 10 IP addresses are scanned in this case. When using a range, either side of the range may be omitted, which Nmap will interpret to be either the minimum or maximum value possible. So specifying 172.16.-4.1 will expand the third octet to include 0, 1, 2, 3, and 4. Here we have one last range example where the second octet is just a dash alone. In this case, Nmap will expand the second octet to be all possible values ranging from 0 through 255. Nmap can also handle classless interdomain routing or CIDR address specifications. IP addresses are described as consisting of two groups of bits, with the bits on the left defining the network address and the bits on the right defining the host identifier. The number after the slash in a CIDR notation indicates the division between the network address and the host identifier and is interpreted as being the number of bits starting with the leftmost bit that makes up the network address. In this case, 29 bits define the network and 3 bits define the hosts on the network. Nmap expands this CIDR notation into a list of 8 IP addresses. Most of the target specification types can be combined. Here are several target lists, all of which are valid. Note that the targets are space separated. In the first example, we're combining an IP address with a DNS name. In the second example, we're using both ranges and lists. And in the last example, we're specifying a small network using CIDR notation and 3 DNS names. Of course, more complex combinations are possible, but I'll let you get creative with those on your own. If you're building a list of target specifications and you're curious to see if it's going to do what you think, you can verify your specification with the -lowercase s, uppercase L scan type, which tells Nmap to perform its target expansion phase and to exit before actually scanning the target systems. So if I execute the command nmap-sl 192.168.1.56/29, the output will look like this. As you can see, Nmap did not try to determine if the hosts were up or perform any port scanning. It simply lists the expanded IP addresses and exits. Passing a large list of targets to Nmap on the command line can be cumbersome. To get around that, Nmap allows for targets to be stored in a standard text file and then passed to Nmap using the -i_L option. Entries in the file can be in any of the same formats we've already discussed and can be separated by one or more spaces, tabs, or new lines. After expanding the target list into individual IP addresses, Nmap performs the host enumeration phase to determine which IP addresses are actually associated with live systems. Once Nmap has that list, the next phase of operation is a reverse DNS lookup on the IP address, trying to turn it into a name. Here we've provided Nmap with the host name www.ibm.com, which during the target expansion phase was turned into an IP address of 23.4.152.139. During the reverse DNS lookup phase, that IP address is turned back into a host name, resulting in the name a23-4-152-139.deploy.static.akamitechnologies.com. In this case, the forward and reverse DN entries don't match. Performing reverse DNS resolution isn't always desirable, especially since it can be slow, so Nmap allows disabling it by specifying the -n flag. There are also times when you want reverse DNS resolution for all IP addresses, not just the live systems. Including the -R flag will enable reverse DNS resolution for every target IP address.